presentation is the Smart Building Control, sponsored again by Zybex Labs.
Hello everyone, my name is Chris and we are the Cyber Smart Building Control System. In today's industry, many companies are still using mechanical thermostats. These thermostats can be inaccurate, they break easily, and they can be incorrectly placed. While some smart devices do exist, they are very expensive, they are hard to customize, and they may not replace existing devices with ease. Our goal was to create a wireless self-troubleshooting HVAC control system that at the same time will be cost-effective and open source. For our project, I focused mainly on the interactions between the hardware and the software. Catherine worked on the software architecture, software programming. Bertia worked on the hardware building, hardware testing. David worked on the hardware manufacturing, and Alyssa worked on the hardware research and hardware schematics. For the software portion of our project, we picked up an Arduino microcontroller and we created a open source thermostat. This thermostat gathers data from a temperature sensor and prints to an LCD screen. We also created a self-healing, fully scalable wireless mesh network utilizing CPU monitors. Our thermostats are able to communicate with each other and with a controller PC. Let's see over here in this diagram over there. The user interface is the gateway in which the user is able to change settings and schedule temperatures for all these thermostats. It's also a place where data is gathered for future data analysis. For the hardware portion, we focused on powering all electronics and creating an enclosed product. We created a backup power circuit that automatically switches the power to a backup battery in the case of power outage so that our devices do not lose their settings. In order to control the HVAC, we set up a triad switching circuit so we can turn on each of the individual HVAC settings. Additionally, we designed and manufactured our own PCB board so we can consolidate all of the electronics and all of the circuitry into a smaller meter unit. Overall, our project should be able to be implemented for both home and industrial environments. It is very easy to install and its troubleshooting capabilities reduce the owner's repair costs. Some of the challenges we faced for this semester for us are lack of knowledge of power electronics, our inability to effectively create mesh networks, and spacing constraints. Some of the future implementations that we'd like to do include interfacing with a website and smartphone applications. We'd also like to be able to monitor weather channels and peak power times to reduce HVAC usage. At this time, we would like to thank Cybex for the opportunity that we had this semester to work on this project, and I'd like to open the floor for questions. Yes?
In this context, what do you mean by open source? So software is open source, freely available, what does it mean?
Open source, by open source we mean that anybody that buys your product can get the microcontroller and they can reprogram it however they want. They can implement other companies, other people, they can implement their own protocols, they can basically rewrite the software on these thermostats however they see fit.
You mentioned the user interface. What is the current user interface?
The user interface is mainly implemented in the controller PC and the external PC. The external PC, the user will be able to change settings, and the controller PC is where you see this interface right here. It's basically, it'll be more for like the building manager, so that he can control temperatures in different places of a building and that sort of things.
So at the moment, the user interface, as you can see the current temperature settings, as well as what you would like your desired temperature to be. There's a button there, it's called the histogram, which shows the history of the temperature, so you can see how your system is cooling down. There's also a statistics button, which gathers data on the average temperature and currently the average cooling time, because the average cooling time is one of the most common troubleshooting things. Say if it's taking too long to cool down, something is breaking somewhere. So you want to get someone to fix your HVAC system before it completely breaks down. And then we have a set schedule button, which is so you can program, at 5 p.m. I want it to be 75 degrees, 6 p.m. I want it to be 76 degrees, and so it'll update that. And then also an error log for also troubleshooting so that you can see the progression of errors over time.
Any other questions?
Did you optimize for cost?
Our design is actually very cheap. Our prototype was about, what, $60, something like that. We do have a budget for that. But it was mainly the microcontroller that was really the most expensive part, and that is like $40. And if it were to be like put in a serial, like a mass production environment, it would be definitely much cheaper since the chips themselves will sell by cents.
Wow, okay, I never heard of a $40 MCU, but.
Well, it's because the company like these little nice boards we have like.
Oh, it's a board that you.
Yeah,
Like a
but if you just buy the MCUs, it's very, yeah.
Okay.
Yeah, there's cents each.
Okay, any other questions?
So is the end user going to be using the external PC or who uses the external PC?
There is both, actually. The controller PC will be the one that holds the protocols for the actual environment. Like in this building, there's going to be like a building manager, and he'll be using the controller PC mostly. And the external PC is just a way of accessing the controller PC. Let's say you can, if you're a building manager and you're in Indonesia, you can still log into the internet somehow and manage the building from an external source.
Did you say you did or did not get a mesh working?
We had a lot of trouble, and we do have a mesh network, but it's not as fully scalable as we would like to be.
Actually, with a couple more weeks of coding, we would be able to get a mesh network up. So unfortunately, the way parts came in, we just ran out of time to fully test it. And also, I wrote like 3 different versions for the mesh network, and it just didn't work each time. So if it had worked, we'd have it. But unfortunately, the code just didn't implement quite as I thought it would.
No other questions? Thank you very much.